Euclidean algorithm. What is Euclidean algorithm? So in Euclidean algorithm, we must recall about the GCD of both integers, or the greatest common divisor of integers a and b, which is, it is the largest integer that can divide both integer a and b. And on the other hand, the Euclidean algorithm is the technique on finding quickly the GCD of both integers. So in solving Euclidean algorithm, here stated above is the algorithm that we need to consider. Euclidean algorithm in finding the GCD of both integers a and b is as follows. If a equals 0 or integer a is equals to 0, then the GCD of integer a and b is equals to b. Since the GCD of 0 and b is equals to b, since the greatest common divisor of 0 and integer b is integer b, and we can stop. And if b is equals to 0 or integer b is equals to 0, then the GCD of the integers a and b is equals to a, since the GCD of the integer a and 0 is equals to a. Since again, the greatest common divisor of both integers 0 and b, or a and 0, is equals to the integer, and we can stop. After that, write a in quotient remainder form, just like what is stated above. A equals b multiplied by the quotient added by the r. Next and last, find the GCD of integers b and r using the same method, using again the Euclidean algorithm method, since the GCD of integers a and b is equals to the GCD of the integers b and r. So here is a other example. Find the GCD of 270 and 172 where integer a is not equals to 0 and b is not equals to 0. So to find the GCD of this equation, we need to use a long division. Long division means 270 divided by 192. So 270 divided by 192, we get 192. 270 minus 192 equals 78. So our quotient is 1 and we have a remainder of 78. So remember the quotient remainder form. We need to rewrite our equation. The quotient remainder form is integer a equals integer b times the quotient plus the remainder. So in this equation, our integer a is 270 equals the integer b, which is 992, multiplied by our quotient, which is 1, plus our remainder, which is 78. Since the GCD of 270 and 192 is equals to the GCD of 192 and 78. Since this is our b and this is our r, we need to find its GCD. GCD of b and r. Here is our other equation that we need to find the GCD, 192 and 78, and so on. This process can continue until we get the GCD of our integers value, which is the 270 and 192. So let us continue. So So let us find the GCD of 192 and 78. Again, we must use again the long division. So 192 divided by 78, we get 102 divided by 178. So 192 divided 78 is 2. 2 times 78 is 156. 192 minus 156 is equals to 36. So we have our quotient, which is 2, and we have our remainder 36. So again, we need to rewrite it in a quotient remainder form, which is integer a equals integer b times quotient plus r. Our integer a again is 192. Our integer b is 78. Multiplied by our quotient 2 plus the remainder 36. So our b here is 78 and our r is 36. So we need to find the GCD again of our b and r. GCD of b and r, which is GCD of 78 and 36. So again, we need to use the long division. GCD of 78 and 36. So long division, 78 divided by 36. So we have 2. 2 times 36 is 72. 78 minus 72 is 6. So we have our quotient 2 and we have our remainder 6. So again, we need to rewrite it in quotient remainder form, where a is equals to b times q times plus r. Our a is 78 equals our b is 36 multiplied by the quotient 2 added by the remainder, which is 6. Again, this is our b and r, and we need to find its GCD. GCD of b and r, which has values of GCD. B is 36 and R is 6. So again, we need to use the long division. 36 divided by 6 is 6. 6 times 6 is 36 equals 0. So now our quotient is 6 and we have a remainder of 0. So if we rewrite it in quotient remainder form, this will be the equation. Integer a is 36 equals integer b's value is 6 times the quotient, which is 6, plus r is 0. So our b and r here is 6 and 0. So we need to find its GCD. The GCD of b and r, which has a value of GCD of b equals to 6 and r is 0. So at this point, we need to remember what was written on the algorithm. If any integer is equals to 0, the answer is the value of the other integer, which is a greater value than the 0. So here, our integer a is 6, while our integer b is equals to 0. So it was said that if integer b is equals to 0, then the GCD of a and b is equals to a, since the GCD of 6 and 0 is equals to 6. So our GCD here is 6. The GCD of 270 and 192 is 6.